Welcome to yet another lesson of A-Level Physics Paper 2, and our topic is Electrostatics. Teacher Agawa Kosma of Back Science Education Consultants, where you always get all these lessons. What you do is just simple. Go to your YouTube and subscribe to our YouTube channel, Back Science Education Consultants, and you're going to enjoy all these free lessons. Previously, we looked at the law or the Coulomb's law of electrostatics, and we said that the force between two charged bodies is proportional to their magnitudes and inversely proportional to the square of separation between them, and the constant was got as 1 out of 4 pi epsilon naught, which is actually is equivalent to, this one is equivalent to 9 exponent 9. And therefore we said that the force between the charges is equal to 9 exponent 9, Q1, Q2, then divided by the square of their separation. That's what we ended with in our previous lesson. We are continuing. We used this one to solve some calculations which were not involving more than one forces, more than one charges. But here we have more than one, more charges. Then what is that interaction? How do you calculate the force between within that interaction? How do you get the force on any charge? For instance, if we have any charge here, it is charge 1, there is another charge 2 here, there is a charge 3 here, there is a charge 4, there is some other charge, maybe called charge 5, maybe there is some charge 6. Then these ones being in the same field, how do I calculate maybe the charge, the force on this charge due to all these charges? How do I do that one? You see, there are quite many, and the way to do it is I calculate the force due to each charge. So the force on charge 1 due to charge 2, how do I get it? The force on charge 1 due to charge 3, the force on charge 1 due to charge 6, due to charge 4, and due to charge 5. And when I get all of them and I sum them up, it gives me the total force on this charge. Remember, force is a vector quantity. Therefore, the issue of the direction is paramount in this. We don't have to forget. That's why in our statement, we shall not forget the term vector sum. We are summing them, but we are considering the direction. We are bringing the issue of the vectors. And this brings us to the principle of superposition of electric force. What is it? This is exactly what I have explained. That the resultant force on any given charge due to a number of charges is the vector sum of the individual forces due to each charge. That is the principle of superposition of electric force. We can take a note. Yes, that the resultant force on any given charge due to a number of charges is a vector sum. Is a vector sum of the individual forces due to each charge. We are going to understand this one more as we apply this one in calculations, and we don't have to go far. Let's go and have example 1. Examples. Examples. So we are going to have charges Yes, this is our question. That 3-point charges are pressed at points A, B, and C are shown here. This is point A. We have a charge of -3 microcoulombs. This is point B. We have a charge of +4. This is +4 microcoulombs. And then point C, we have a charge of -7 microcoulombs. This distance from here to here is 0.1 meters. This is 0.05 meters. Find the resultant force on the charge at B. So you can see that this charge at B will experience a force from a charge at A, and we also experience a force from a charge at C. Now, the magnitude of force on this charge at B will be the vector sum of the force due to charge at A and the force due to charge at C. That's why you are saying there is superposition, there is addition, there is summing up of the forces, and that is the principle that we follow. So let's first see, how do I do this? If I get this charge at B and I try to bring it towards this, does it go there? Yes, because this is positive, this is negative. So if I try to take this charge at B in the direction of A, it will go there, meaning that our force will be in this direction. That is to say, if I can call it force on charge at B due to charge at A is in this direction, as you can see, it will be in that direction. And how big is that force? Remember, force equivalent to 9 exponent 9, then Q1, then Q2, then out of the separation square. Therefore, the force on B due to charge at A, this will be equal to, that will be equal to 9 exponent 9. That one came from 1/4 pi epsilon naught r. You can check in the previous lessons. Then the charge 1 is now this charge 4. It is in microcoulombs, so that is exponent -6. Then there is now this other charge. We don't take the sign, we leave it. It was to help us get the direction, so that is 3 exponent -6. Then divided by the square of the separation, which is 0.1. And this force, when you press very well on your calculator, you get 10.8 newtons. That is the force. In which direction? Towards the charge at A. Let's now calculate the force on charge at B due to the charge at C. So force on charge at B due to charge at C, following the same thing, will be 9 exponent 9. Then this one is 4 exponent -6. Then this one is 7 exponent -6. Then the separation is 0.05 in meters. If this one is not in meters, it's good to first do it and change to meters. And when you press this one on your calculator, you get 100.8. 100.8 newtons. But in which direction? When I get this body, this charge, I try to move it in this direction. This is positive recharge, this is negative recharge. As well, this one will go in that direction. That is to say, this force will be in this direction. Now let's do some simple diagram. So this is our point B. There is a charge. It is experiencing this force, which is 100.8 newtons, and is experiencing this force in this direction, which is 10.8 newtons. So what is the resultant? Remember what we studied in senior 2? This one in this direction, this one in this direction. So we may decide to subtract the big one minus the small one, then we take up the direction of the bigger one. Therefore, the resultant force equals 100.8 minus 1 minus 10.8, and this will give us 90 newtons. By so doing, we have got the resultant force on a body at a point B due to the different charges situated at different points. We need to do another example. Let's go to example 2. Yes, calculate the resultant force on each of the charges below. So we have a charge of plus 2 microcoulombs, we have a charge of minus 3 microcoulombs, and a charge of minus 4 microcoulombs. So we need to get the resultant force on each of them, because when they are in that same field, this charge will experience a force due to this charge, and will also experience a force due to that charge. This one will experience a force due to this one, and also a force due to that one. As well as this one of negative 4 microcoulombs will also experience a force due to this and a force due to that. So, can we be able to calculate the magnitude of each of the resultant forces on each of the charges? Of course, yes. Let's begin with maybe the one at P. If we can begin with the one at P. So force on charge at P due to charge at Q is equivalent to what? You first get this charge, assume as if you are taking it in this direction. Does it go there? Yes, because this is positive, this is negative. There is attraction. So if I take this one in the other direction, it will go there. So this force, I can just represent it, and I show it will be in that direction. Then what is the magnitude? 9 exponent 9. Then this one, microcoulombs. You have to change to coulombs. Then this 3 also to coulombs. Then the separation is 2 centimeters, which you have to change to meters, and this becomes 0.02, and that is squared. And when you press that one on your calculator, you should be able to find that this force is equivalent to 135 newtons. That should be the force that you get. Let's now calculate the force on this charge due to this one. That is the force on charge at P due to charge at R. Which direction? If, don't look at this, assume this one is not there. If I get this charge, I try to move it towards this direction. Does it go there? This is positive, this is negative. Does it go there? Yeah, somebody is saying yes. You are right. It goes there. Meaning also this force will be in the same direction. Same direction towards R. Okay? So, what about the magnitude? You don't have to forget the constant first. Then, of course, this is 2 exponent negative 6. Then this one is 4 exponent negative 6. Then the separation. What is the separation between P and R? From here to here is 2. This is 4, meaning this is 6 centimeters. So this becomes 0.06 squared. And when you press this one on your calculator, you are supposed to get 20 newtons. In which direction? It is shown here. Therefore, what is then the resultant of the force due to this and force due to this on this? So, the resultant equals, you can see they are going in the same direction. Maybe I can show. This is our point P. There is a force. This one, 135 newtons. This one, 20 newtons. So how do we get the result? You can see that they are in the same direction. Therefore, we add them. So the resultant force is equaling to 135 newtons plus 20 newtons. And this results into 155 newton. Towards which direction? This is a force. You have to remember. Towards which direction? In the same direction. You have to quote it. You can quote it in any way. You can say towards R, or in the direction of R, or in the direction of PR. Anything that at least somebody can see that you understand that you have stated. So I can say in the direction maybe PR. Yes, the same direction, or P or to R. Maybe in the direction to R. And by doing so, you have explained, just like we did here, that the resultant force here was in the direction of what? Of C. Because this one subtracted this, it gave us this one. But in which direction? In the direction of what? The direction of C. You don't have to forget. We need to move on. That is only the force on P due to force on Q, not do the charge on Q and charge on R. I want you now just have a minute and do this. I'm seeing you. I want to continue seeing you until when you just handle this one and just do a sketch to get the resultant force on Q due to the force, the charge on P and the charge on R. Just 1 minute. Do some sketch. My eyes on you. You may be home, but I'm seeing you. Yeah, I'm waiting for you to do that sketch and try to do something related to this. Yes, do it. We were A-level students. Yes, I know you have the potential to reason out things. Please, go ahead. It is you to do. I will mark you. I will believe that you have done something related to what I'm going to do. Congratulations. Thank you very much. And I know next time you'll actually even do better and more excellent things. Let's go. Now, the force on charge at Q due to charge at P and R. Let's begin with this one. Our interest is the charge at Q. So we want force on charge at Q due to charge at R at P. Let's begin with P. Is in which direction? If I get this one, I try to move it in this direction. Does it go there? This is negative recharge, this is positive recharge. Yes, there is attraction. So that force will be in this direction. So it will be in that direction. And the magnitude will be, I know you have written 9 exponent 9. Then this one is 3 exponent negative 6. Then that one is 2 exponent negative 6. Then the separation is 0.02 square. And when you press that one on your calculator, you're supposed to get something that is supposed to be 135 newtons. That's the force in this direction. What about the force on this due to that? The force on the charge at Q due to charge at R. Get this. Try moving it this direction. Does it go there? Try. Negative, negative. Bring it. This one will not be attracted, will be repelled. In other words, as you try to bring this one this side, it will be like, no, don't take me there. I am going there. So even that force will be in this direction. The force on this, due to this one will be pushing this one to go in the other direction. So that force will be in that direction. Then the magnitude, 9 exponent 9. Then, of course, the charge itself, 3 exponent negative 6. Then, this is 4 exponent negative 6. Then the distance between this and this is 0.04 squared. And when you work out that force, I'm supposed to get 67.5 newtons. How do we get the resultant? The resultant force is equivalent to, you can see, this one is going in the other direction, this one is going in that direction, meaning the resultant force will be in the same direction. Look, this is our charge. It has a force, and these forces are in the same direction. One is 67.5, another one is 135. So the resultant force will be 135 plus 67.5, and the resultant force will become 202.5 newtons. In which direction? This direction. Which direction is that? I can say in the direction of P. It is towards P. It is towards P. So I can say in the direction of P. As you bring in force, you must bring in the direction. I know we are moving together. I know we are reaching somewhere. And in our language, we have a saying that an odd child, once is being bathed, we also try to help him or herself. We help the mother in doing so. So I want you to be like that, for you are not a child. You are in A level. So you are a young adult. So that young adult in you to do for I, the force on charge at I due to charges at P and Q. Just to do that. Then after doing it, you have always been following us. Don't forget to send us the work. Check on our channel, our information is there. BSc, that is our channel name. BSc, Back Science Education Consultants. The real definition of continuity and the home of understanding sciences. Do that, then you can reach to us in case you have a question. Also, when you feel you have passed, send it to us so that we can celebrate with you and we can keep guiding you where need be. That is it for now. Please subscribe to our channel and share and invite others to also subscribe so that we continue learning.